Thanks for tuning in to the Oxygen Alliance YouTube channel, where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell. Hello everyone, thank you for tuning in for week 29 of our Oxygen Concentrator Talk call brought to you by the Oxygen Alliance. My name is Mario Lungu, as usual. Very pleased to be hosting the call. Joining me on the call today are my colleagues, Amapri Rai and Timothy Mtonga, along with our technicians from OpenO2 and Sunrise. So on the technicians panel today, we have Paulina Mohosho and Masofa Mojaji joining us from Johannesburg. We have Kuwinda Singh joining us from Chandigarh, India. And we have Georgie Kwanga, Obre Chinkunda, and Teto Sinjani joining us from Lilongwe, Malawi. So for those of you that may not be aware, the Concentrator Talk Call is a virtual meeting that the Oxygen Alliance hosts every Thursday from 2 to 3 p.m. Central African Time. And here we discuss the different aspects of concentrator assessment, use, and maintenance. So if you have some issues that you'd like us to help you out with your device, you can always send those problems to us through our email address, info@oxygenalliance.org. And our technicians will respond to those questions. Or in case you have any questions in the questions that we have for this week, you're also free to just either paste those questions in the chat, or you can come off mute and ask the questions, and then we'll help each other out. For our topic of interest today, we'll be talking about filters in oxygen concentrators. So we also have polls at the end of some of the questions. So as usual, we'll respond to them once they pop up. So now to jump on to our questions. So our first question of the day says, we have received one Philips Everflow oxygen concentrator with a problem of not powering on. We tried changing the power socket, but it was the same status. When we opened the machine, we found that the fuse was blown off. We replaced the fuse and the machine was turned on. The fuse got blown off again. What can be the reason? Please suggest a solution. So I will ask George to answer this one.
Thank you so much, Maui. Generally, this type of problem occurs when there's a shorting of components of wiring inside the concentrator. So what you're supposed to do is to find the fault, you need to open this concentrator. Basically, you can use 8mm socket spanner and the Phillips screwdriver. So the PCB for this model is located on top, below the power on/off switch. So what you have to do is to take out the PC board out of the concentrator by removing all the connections. So when you have the PCB, you first check the condition of the valistor on the PCB. So as I said, when you open the concentrator and you have removed the PCB, the one that you can see in the graphics. So first of all, what you have to do is to check the condition of the valistor. As you can see in the graphics, the yellow thing there, that's a valistor. So if you notice that it is bent, because you can physically see the condition, you need to replace with the new one. Basically, the valistors are easily accessible in the market, so you can find almost everywhere. Generally, this part of the PC board is damaged due to power fluctuations. So we strongly suggest that you need to use voltage stabilizer to overcome this kind of the problem. Thank you so much.
Thank you very much, George, for that response. I hope that explanation will at least give you direction on how to go about solving a problem. In case you have some questions on the explanation that he has just given, you're always free to ask, and then he will respond to any follow-up questions that you might have. All right, it seems we do not have any questions there. So now move on to our next question. So the question says, we have 5 oxyflow oxygen concentrators at our hospital. Generally, when there is a problem with the machine, the display shows H01 or H04 alarm, but it does not indicate which part is faulty. Is there any process to find out which part is faulty in the oxygen concentrator? So I will ask Aubrey to respond to this one.
Hello, can you hear me?
Yeah, we can hear you now.
Okay. So generally, all oxygen concentrators are installed with alarm systems showing the problem with the machine. Now, in case of the oxyflow 5, when it shows H01 alarm, it indicates that there is a problem with the operating temperature of the machine. The operating temperature recommended for the oxyflow is usually between 10 to 37 degrees Celsius. In cases where the temperature is below or above the normal operating range, the alarm goes off. And the various causes for this alarm can be a faulty cooling fan, no proper ventilation to the machine, and a faulty temperature sensor. The H04 alarm indicates low purity. When oxygen purity goes below 82%, the machine sets off the alarm. Now, to find which part is faulty, you have to connect the pressure gauge between the compressor and the pneumatic valve. And then you have to turn on the machine and see if it's working within the recommended pressure ranges of 10 to 22 psi. If the pressure is low, it means there's a leakage or the compressor needs to be serviced. If the pressure is high, it means there's a blockage or the seatbelts need to be refilled or replaced. And if the pressure is erratic, it means the pneumatic valve is faulty. So you have to clean it if it's possible or replace it with a new one. Thank you.
Thank you very much, Aubrey, for that response. I hope that was detailed enough, and hopefully it's going to help to solve your problem. But in case you still have any further troubles, you can always reach out to us for further guidance. So if we have some questions from the audience, as usual, we're always free to ask. And if we have some other comments as well from the other technicians, we are also free to ask. All right, it seems we do not have any questions there. So we'll move on to our next one. So the question says, I am a field technician working for a certain company. I wanted to know if there is any way I can measure the flow delivered by the oxygen concentrators. So I will ask Masofa to respond to this one.
Thanks, Moabi. Yes, there's a way that flow can be measured. There's a device called a flow pen, also known as a liter meter, shown there on the slide. This device is used to measure and verify the liters per minute flow that the concentrator has been set to supply to the patient on the flow meter. To use the flow pen, you will need to connect the tube to the bottom where the numbering starts. Sorry, where the numbering starts, and connect the other end of the tube to the concentrator outlet port. Keep the device in the upright position when testing the flow. The flow reading on the flow pen should be the same as the one on the flow meter. And note that the tolerance is 0.5 liters per minute. If the reading you get is below or higher than 0.5 liters per minute, then it means that the flow meter might need recalibration. So you need to replace the flow meter and to get the correct flow output. If you do not have a flow pen, you can always use an oxygen analyzer to check the flow. There are some oxygen analyzers that comes with a built-in flow sensor, and you can also use this to check the flow rates. Thank you, Mwavi.
Thank you very much, Masofa, for that response. I hope that was detailed enough and that will help to answer your questions. If we have questions or comments from the audience and the other technicians, please let's contribute to that explanation. Okay, it seems we don't have any questions there, so we'll move on to our next question. So the question says, I have an airstep with no flow meter and I would like to replace it with a new one. At the moment, we have no spare airstep flow meters in our workshop. We do, however, have a DeVilbiss 515 flow meter that is not being used. Can I take that flow meter and use it on the airstep? So I will ask Aubrey to respond to this one.
Thank you, Maui. A flow meter is a device used to regulate the flow and the volume of oxygen gas going to the patient and is placed just after the pressure regulator. The pressure regulator is a device designed to maintain outlet oxygen gas pressure to a desirable value. Different flow meters come with different flow rates. Mostly, the most oxygen concentrator flow meters come in 5 liters per minute, 10 and 15 liters per minute. Some flow meters designed for different concentrator model, but with the same flow rate, may not be interchangeable because of the differences in position of the inlet and outlet ports and differences in the pressures that they were calibrated at. Different flow meters are designed for use at different pressures. For example, the flow meter on the DeVilbiss oxygen concentrator is designed for use at 8.5 psi, which is 58.6 kilopascals, at flow rates up to 5 liters per minute. So unless the flow meter on the different concentrator model has been calibrated at the same pressure and has the same footprint, this is to say they have the same positioning and shape of the inlet and outlet ports, they are not interchangeable. Thank you, Mar.
Thank you very much, Aubrey, for that response. I hope that will help you to identify a problem and solve it. But if you still have any issues, you can always get back to us and we will help you with any further problems that you might have. If we have some questions from the audience or the other technicians, some comments, we are free to do so. Right, it seems we do not have any questions here. So we'll now move on to our next question. So the question says, I work at Nsanje District Hospital. Last week, we experienced a power surge and one of the concentrators, model ASF, started malfunctioning. It is producing a popping sound and not producing any air on the patient's outlet. What could be the problem? So I'll ask Nteto to answer this one.
Thank you so much, Maui. So an ASF concentrator has multiple components that require power to operate. And these components include the compressor, solenoid valves, etc., etc. So the popping sound is surely coming from the compressor's relief valve. The compressor produces compressed air that needs to be directed to the sieve beds through the valves, but the solenoid valves are switching on, hence it is releasing the air through the relief valve, and that is the popping sound you are hearing. So it is unlikely that the solenoid valves are damaged, but rather they are not receiving power that comes from the control board. So air-safe concentrators have different board designs because they have gone through multiple iterations. So some have LEDs on the board that will allow you to easily notice if the board is malfunctioning, but others don't have LEDs, and this requires you to have a multimeter to test if there is voltage going to the solenoid valves. So if there is a power surge, like what happened there in Sanje, the control board can easily get damaged. And in the graphics there, we see we have a bent varista. So the varista gets bent, so the varista can blow up, and it is clearly visible as it tears off. So you can see in the graphics there. So this varista, its part number is P275L20, and they come in different colors, because you might be wondering that, you know what, I found that it's a red one that is brown, but then when I went to the market, I found a blue one or a yellow one. So just take note that they come in different colors. So moving on to the other components that can bend. So the two resistors. So if you can move to the next slide. So the two resistors also get bent and they become dark. See, but sometimes they don't. So in such a case, you need to actually desolder these resistors and test their resistance using a multimeter. And it's good to know that these two resistors measure 1 ohm and they are 1 watt each. So if you try and replace with a quarter watt, you might actually fly that resistor because it's on a smaller size. So the last part to change is the capacitor. So this should be the last part after maybe changing the value. So by changing this capacitor, it has to be like a 100 nanofarads and 300. So by doing that, the board should be functioning again, and the concentrator will be operational. Thank you, Maui.
Thank you very much, Mteto, for that response. I hope that will help you to fix your problem. Just one thing to point out, Mteto. So there are some boards which come with a fuse. I think if we go back to slide number 5, so there was an image of a burnt varista and a fuse there. So sometimes you might easily confuse the two, because there are some models of varista, as Mteto pointed out, that they are yellow in color. So you just need to be careful that you are swapping it out with the right components. Yeah, so as we can see in the graphics, we have an arrow pointing to the varista, and just below that, we have a yellow component. So that one is the fuse. So the fuse is commonly found in this version of the control board. So when replacing these components, just make sure that you are sure of the part number and the components, because sometimes they might look similar and you might end up replacing it with the wrong components, which might cause further problems. So if we have further comments from the audience and the other technicians, we are free to also add those comments. Okay, it seems we do not have any questions or comments there. So we'll now take a short break from our questions and now jump on to our topic of interest. And today we'll go into further details talking about filters that we find in oxygen concentrators. So Paulina is going to take us through that explanation. So over to you, Paulina.
Thank you, Mwabi. So as Mwabi has mentioned, that we will be talking about the filters that we find in oxygen concentrators. So we will be talking about the ones that we find in the stationary concentrators and also in portable concentrators. So as we may all know, that oxygen concentrators take in air from environment where the machine is being operated. This air contains millions of particles, which includes dust, dirt, smoke, molds, bacteria, and other pollutants, some of which are micron-sized and cannot be seen by the naked eye, and they can penetrate through very tiny openings. Particles of this size can easily enter and clog the internal components of the concentrator, and they can also penetrate deeply into the lungs of the patient using the machine. So to prevent this, concentrator air filters were designed to help protect the oxygen concentrator and to also protect patients from the risk of infections that can be caused by inhaling those tiny particles from the oxygen coming from the concentrator during use. There are different types of filters found in oxygen concentrators which serve more or less the same purpose in ensuring the concentrators run smoothly and delivers good quality oxygen needed by the patient. So this is how these filters work. So their purpose is to clean the ambient air that is thrown into the machine by catching the particles which I mentioned earlier, and prevent them from entering into the system. So these filters differ in material and they also differ in quality, and that determines the size of the particles that can be captured. So now we will go through some of these filters. So it's for both the stationary and the portable oxygen concentrators. So firstly, we have the gross particle filters. So that is the first slide. We have the gross particle filters, and those are in a form of foam filters and fine mesh screens. These filters are on the first stage of filtering. So the ambient air goes through them and filters whatever particles before passing into the machine for more filtering and oxygen generation. These filters are located on the outside of the machine for easy access. They're mostly found on the back and the sides of the machine. In some machines, though, they are found in the front. The great thing about these filters is not only that they can capture particles, but they are also reusable. So as much as they are reusable, they need to be well taken care of to prevent regular replacement. They would need to be replaced if they are broken or they are torn. So a very important thing for users to know about these filters is that with every air intake, the contaminants trapped by these filters build up and eventually clog, and the result is the reduction of airflow into the machine. So these filters must be cleaned at least once a week or twice a week, depending on the environment where the machine is being operated. So to clean the sponge filters, you would just need to wash them with soap or a disinfectant, rinse them thoroughly to let them air dry. Only put them back into the machine when they are completely dry. For the mesh filters, the fine mesh filters, you also need to use soap or a disinfectant to clean them. But then you would also need to use a fine brush, like a toothbrush, to clean off any dirt that might have clogged those small mesh pores. Also rinse them thoroughly and let them air dry before putting them back onto the machine. So there are some concentrators that do not have removable filters, like the latest developers. So in those, you would have to clean the air intake window. So you'll need to clean it regularly to prevent any mold build-up. Second slide, please. Secondly, we have the inlet filter. So those are your HEPA filters, the paper filters. Yes, so these are the filters that we usually call the second stage filters. So air goes through these filters and they filter air that goes into the compressor. When these filters are clogged, they cause the compressor to run at the maximum speed in order to make more air, This then results to take in more air, This then results in the compressor overheating and the piston rings getting damaged. The air intake filters are for a short-term use. They cannot be cleaned and they cannot be reused. It is recommended to replace the HEPA filter every 6 months and the paper filter every 5,000 hours of use. The long-term use of these oxygen concentrators in dusty environments requires the filters to be replaced more frequently. These filters, the HEPA filters and the paper filters, these are found in stationary concentrators, and they are located in the filter house, where the cabinet can easily be opened and removed to clean the area or to replace the filter. The HEPA filters should not be interchanged between different models of concentrators. As much as the design might look alike or might fit into the machine that you are using, you should not interchange them in order to prevent premature breakdown of the concentrator due to overheating. And also, the machine should not be modified in order to fit in a HEPA filter that might look like the original HEPA filter of that machine. So for the paper filters that is found in the OxyFlow, it looks like an oil filter. So these oil filters should not be used in OxyFlow machines. They have a still on both ends that prevents proper air circulation when they are installed in the OxyFlow. So I've come across a machine that I was repairing, and this oil filter was installed instead of the proper OxyFlow 5 filter. So it is very important to put that information in. So for portable machines, this second stage filters cannot be easily accessed. They are only replaced by technicians. They must be checked when the machine has been sent in for a service. So the good thing about these POC filters is that they don't have that 6 months service time frame whereby they tell you that you should replace them after a certain time. So the patients don't have to worry about bringing in the machine every 6 months in order to replace the filter or have it checked out. This can be replaced when the filter is clogged. And for these filters to clog, it takes a very long time. It can take over 12 months to happen. But for machines that operate in very harsh environments, it can happen that the filter might need to be replaced in 12 months. So when it needs to be replaced, also you would notice also the compressor will start running it will be very noisy when it starts running. So the patients will be able to know that the filter now needs to be replaced. That slide, please. Okay, so now we have the compressor filter. So this filter is found in DeVilbiss machine. So as we might have heard from DeVilbiss weeks ago, this is like one of a kind filter designed by DeVilbiss. So this adds an extra layer of filtration of air going into the compressor. So this filter has a 3 years usage time and can be replaced as needed. Next slide. Next, we have the bacteria filter, also known as the microdisc filter. This is the final part, and it is on the final stage of the filtering system before the oxygen is delivered to the patient. This filter filters any bacteria that may still be in the system after all the filtering stages. This filter is installed to prevent the patient from inhaling any harmful bacteria that could cause any respiratory problems or infections. The filter is an internal part, and it should be replaced as necessary or at an average of like every 5 years. Next slide. So we also have the output filter. This is also a final stage filter that is found in portable machines. The output filter is located just underneath the cannula bulb of those small portable machines. These filters are not reusable and may be replaced yearly if the machine is used by one person. If the machine is used by different people, then it should be replaced between patients because there may be some bacteria coming from the patient during inhalation that might be trapped on the filter if used by a different person. But if it's used by the next person, they could easily get infected. This filter must also be checked when the machine comes in for a service, because if it is clogged, it will limit the amount of oxygen that is being delivered to the patient. So to replace this filter, you'll just need a cannula bulb tool or just a needle plier to unscrew the cannula bulb in order to get to the filter for replacement. Next slide. Okay, so next we have the sieve beds filters. So these the filters that filters the air that comes into the sieve tanks to prevent any particles from entering and contaminating the zeolite. When these filters are clogged, they affect the purity of the machine. When refilling the sieve beds, you will need to check these filters. If they are dirty, you would need to wash them. If the filters are washable, and let them air dry before use. Replace them if they're damaged to get a good quality oxygen concentration. So for portable concentrator sieve bed filters, like those of Inogen machines, they cannot be washed. So if you have one that is clogged, you would need to replace them. Next slide. Lastly, we have the noise filters. These filters are well known as mufflers or silencers. These filters are used in concentrators to reduce the loud exhaust noise during operation. Oxygen concentrators have different designs of these filters. Some are reusable and some are not. When these filters are clogged, they cause the malfunction in the machine, which result to low purity issues. So for non-reusable mufflers, like the one that you see on screen, the white one is an Oxlife Independence muffler. So like those ones, they are not reusable. So frequent checks are a must on that. So when you perform a repair or service on that machine, you would need to check if the muffler is still fine or if it needs to be replaced. The reusable mufflers have sponges in them that absorb the noise. These sponges do not get damaged, as their purpose is to only absorb the noise, but they can get clogged with dirt and zeolite. So it is important to check and clean them if needed. So in conclusion to today's topic on filters, it is very important for us technicians and field technicians to always remind the users of these machines and also the operators of these machines of the importance of the filters. So the filters that they are responsible for, they would need to take care of them, as that decreases it decreases the requirements for service. So if these are taken care of, then the machine will not need much service, like it would only need major services. All right. So that would be all for today's topic of interest. Thank you.
Thank you very much, Paulina, for that topic, and I hope I've learned a lot from that. Filters are very important, and if we don't take care of them, as you pointed out, then we are going to shorten the lifespan of our devices. So if you have any questions or comments on the topic that Paulina has given us, we are free to do so. Yes, Amapri, I see you have a hand.
I do. I think this was the perfect segue. So I think everyone has been receiving our emails on this call, and for those watching later, one of the things as the Oxygen Alliance that we are trying to do is to make filters for the different types of oxygen concentrators available as close to locally or regionally as we can. So we, of course, need your help as members of the Oxygen Alliance and technicians that are regularly working on concentrators. Please do tell us what models you are seeing. It can be as little information as you have, or of course, as much information as you can provide. We are amassing a list of all the different concentrators that we're seeing and the filters that are needed for them. But of course, we want to hear from you. So feel free to drop it in the chat. Feel free to send us an email. It doesn't matter how many models, whatever you come across, whatever you see, maybe the easy to find ones, maybe the harder to find ones. As we just heard in this topic of interest, filters are essential. And we want all of the equipment that is being used in these environments to last for the long term. So do let us know what concentrator models you're seeing. Thanks, Maui.
Great. Thank you very much, Amapri, for that. So as she has pointed out, please let us know. I think we'll share your email address with us in the chat so that you can share with us those models. All right. So now back to our questions. So we'll be moving on to the next one, which says, during preventative maintenance carried out at COVID-19 Isolation Center, I came across 3 oxygen concentrators that were connected to patients but did not have cabinet filters. No one knew where the filters were placed, and we had no spares in our workshop stores. Was it safe to continue using these oxygen concentrators? If not, what could be the effects of their absence to both the patients and the concentrator? So I'll ask Aubrey to respond to this one.
Thanks, Maui. So, no, it is not safe to use concentrators without cabinet filters to both the patient and the concentrator. As it has already been mentioned, the function of cabinet filters is to prevent large dust particles from entering the concentrator. The small dust particles that make their way through the cabinet filter are trapped by the intake filter. This ensures that clean air is fed into the compressor and subsequently the required oxygen purity is reached. Hence, running the oxygen concentrator without the cabinet filters may result in quick collection of dirt in the intake filter. And once the intake filter is clogged with large particles, it will have the following effects. Firstly, the pressure can be affected, which may end up affecting the purity of the oxygen that is being delivered to the patient. The lifespan of the intake filter will also be shortened, thereby increasing maintenance costs. And in very dusty areas, some of the dust may find its way into the internal components of the concentrator, such as the compressors and the valves. And if the intake filter is overloaded with dust, thereby affecting the performance of these components. Therefore, if there are no spare concentrators with cabinet filters to be used in the ward, and there is an urgent need of the concentrators, I will recommend that you use gauze bandage as a cabinet filter for a short period of time while you look for the misplaced cabinet filters or waiting for new cabinet filters to be purchased. In addition, the cabinet filter should also be cleaned with water on a regular basis, as it was told in the topic of interest, in order to keep the concentrator running properly and have it produce the oxygen purity that is within the recommended levels. And if there is need to keep the concentrator running while the filter is being cleaned, make sure that a spare filter is available and it is used. It is recommended that the cabinet filter must be cleaned weekly with soapy water and should be left to dry before it is put back on the concentrator. Thank you.
Thank you very much, Aubrey, for that explanation. I hope that's clear, and hopefully that is going to help you to fix that issue. So if we have any questions or further comments on the explanation that he has just given us, we are free to make those extra comments. Right, no comments. So we have a poll at the end of this question. So Amaprit, if you would please launch that one up.
I will do so. And if you can please remind everyone how to access the polls.
Yes, so if you are joining us using your mobile phone, if you go to the bottom right of your screen, there is a menus option. If you click on there, a window will open up where you have the activities button as one of the options listed. If you click on the activities button, another window opens up where the pause menu is one of the listed options. And if you are joining us from a computer, you also go to the far right on your screen. The icon on the far right is the activities button. So if you click on that, it will open up a window where the pause menu is one of the listed options. So that's how you get there.
Thank you for that explanation. So our question was, have you ever used an oxygen concentrator without a cabinet filter? And I am happy to say that almost everyone has said no. So hopefully with this question that we just heard, we now understand that we should not do that. We also do have a second poll question with this one, and I will launch that now. And this question is, did you know the negative effects of using an oxygen concentrator without a cabinet filter before now? And we'll give everyone a little time to answer that question. I think for me personally, I knew it was a bad idea, but I'm not quite sure I knew totally why. So it was a very helpful and interesting explanation. And it looks like this vote is a little bit more split, where we do have some people who knew and some people who did not. Back to you, Maui.
Great. Thank you very much, Amapri, for that poll. So we'll now move on to our next question, which says, I am a biomedical technician working as a trainee at a health clinic. I am carrying out preventative maintenance on an oxygen concentrator, but currently we do not have an oxygen analyzer which I can use to test the oxygen purity of these concentrators. There are pressure gauges that I can use to test the pressure at the patient outlet and also the sieve bed output pressure. If I test the pressure and find out that the concentrators are producing the required pressures, can I conclude that the concentrators are working perfectly? And what is the recommended pressure at the patient outlet? Is it the same for all concentrator models? So I will ask Mteto to respond to this one.
Thanks once again, Maui. So oxygen concentrators use the principle known as pressure swing adsorption, abbreviated as PSA. The fact that under higher pressures, gases tend to be trapped onto the surface of a solid. So in the case of the oxygen concentrators, the compressor produces pressurized air, which is filtered in the molecular sieve beds. So it is the high pressure that makes it possible for the nitrogen to be absorbed by the zeolite so that we can have some rich oxygen air at the end of the sieve bed outlet. So when the pressure drops, the nitrogen which was trapped by the zeolite is released from the concentrator to the atmosphere through the exhaust muffler. So to answer the first part of your question, although pressure is an important factor in the production of oxygen, it is wrong to come to a conclusion that an oxygen concentrator is working perfectly by just having the required pressure at the output. So another main thing to check on an oxygen concentrator, apart from the pressure, is the purity of oxygen being produced by that particular oxygen concentrator. So as such, you need to test the purity of the concentrator before you conclude that the concentrator is not working. The concentrator is working as required. This is because a concentrator may be working at the recommended pressure, but the oxygen purity may be below the recommended oxygen purity. So when we talk about the recommended, we're talking about 85 up to like 95.6%. So therefore, in your case, I would recommend that you wait for that oxygen analyzer, that it is available, and test the purity of all the concentrators you are working on before you deploy them to the hospital wards. Thank you so much, Maui.
Thank you very much, Mteto, for that response. I hope that gives you a clear understanding of what to do and what not to do. So it's always important to have the oxygen analyzed because that now gives you the clear picture of the performance as he has just explained to us. So we have other polls at the end of these questions. So Amma, please run those polls.
Yes. So and this is another question with 2 polls, but our first poll is, have you ever tested a concentrator patient outlet pressure using the pressure gauge? And we'll give it a little time to get an answer. Seems like we're getting a lot of yeses. Okay. Mostly we had everyone vote yes. And our next poll question, do you understand how the pressure swing adsorption process works? This, I think, is very essential to how concentrators work and PSA plants, actually. And it looks like we've got all yeses for this one. All right, Maui, back over to you.
Okay, great. Thank you very much. So moving on with our questions now. So our next question says, I am working on an Invacare Perfecto 2. The concentrator has a problem of low oxygen purity. I have refilled the beds and checked for leaks. I have also tested the compressor and it seems to be in a good working condition. However, the purity hasn't improved. What more can I do to improve the purity? So I will ask Kowinda to respond to this one.
Thanks, Mavi. Since most of the work has been done to correct the problem of low purity, the other probable cause would be the control board or the PCB. The control board controls the switching cycles of the oxygen concentrator, among other things. The switching cycle is in oxygen concentrator can be based on either pressure or actual amount of time taken. So it can be pressure based or the time based. For oxygen concentrators that base their switching cycle based on pressure, they measure the product tank pressure. When the product tank pressure reaches a certain specified value, the cycle switches. So that is to say that the bed which was being fed will now be fed with the air, and the bed that was being fed with now will be purged. That will be purging the nitrogen out. For oxygen concentrators that base their switching cycles based on time, when bed A has been fed for X amount of time as defined by the manufacturer, the cycle switches just as explained. For most 5-liter models, the filtering time is 6 seconds. So after 6 seconds, the seabed changes from one to the other. But it depends anyway on the models. The Invacare Perfect O2V switching its cycles based on the product tank pressure. So pressure in the product tank reaches 20 psi. The 2 beds switch. That is the bed that was being fed will now be purged. So as we can see all the working diagram of pneumatic working diagram of Perfect O2 in the graphics. So to correct your problem, you need to first check the product tank pressure by connecting a T-connector on the pipe going to the product tank and connecting a pressure gauge to the T-connector. Monitor the pressure fluctuations and note if the cycle switch when the product tank pressure reaches 20 psi. So if the switching occurs at a pressure significantly lower or higher than 20 psi, it shows that the circuit board is faulty and hence needs replacement. If you are still getting low oxygen purity, check the integrity of the tubing of the pressure transducer on the circuit board. So check and confirm that the tubing does not leak. If it does, either replace the tubing or tighten it further with the tie wraps. So thank you.
Thank you very much, Paulina. Oh, sorry, Kowinda, for that explanation. I hope we all understood that one, and it has given us all the details that we need to fix that. But in case you have some comments that would like to make, we are always free to do so. Okay, it seems we do not have any questions there. So looking at our time, we are running out. We still have a few minutes, so we'll just take one more question and then end our session. So our last question says, I am servicing an oxygen concentrator whose compressor is not working and is rated 110 volts. I have a spare compressor of the same model, but it is rated 220 volts. And the voltage that we get from our socket outlets is 220 volts. If I replace the 110 volts compressor with a 220 volts compressor, what will happen? Will the unit work? So I will ask George to respond to this one.
Thank you, Maui. Every concentrator model has a voltage or power rating, which is likely to be different from that of the other concentrator models. For example, the concentrator which is rated 110 volts will obviously have 110 volts compressor, circuit board, and even the cooling fan. All those rated 110 volts. This is the same with 210 volts rated concentrator. So it will also have the circuit board, the compressor, and even the cooling fan and other components rated 220 volts. So to answer your question, if you replace 110 volts compressor with 220 volts compressor and supply unit with the 220 volts, you can damage other components of the concentrator, which also depend on the voltage rating of the concentrator. Thus, the unit will not work. As such, we advise you not to proceed to replace the compressor. Always check the voltage rating of the oxygen concentrator, which you usually stated on the sticker at the back of the concentrator before connecting to the mains. It can also be found in the user manual or in the service manual. Ensure that only the recommended voltage rating is supplied to the concentrator. Thank you so much.
Thank you very much, George, for that response. I hope that maybe helps you to understand that. So always make sure that if you are changing these components, just make sure that they are of the same power rating. Otherwise, it's just going to be a problem. So if we have any questions or comments on this one, we are free to make those comments. All right, it seems we do not have any comments there. So reaching this far, we have now reached the hour mark, and this brings us to the end of our call today. And I would like to thank you all for joining us. As usual, we are always happy to see here. We are always happy to get all the questions, and we're happy to help you out with the solutions. So please, if you have any problems, always reach out to us, and we are always willing to help. We have a YouTube channel where all our recorded sessions of our previous calls are uploaded. So in case you missed some of the sessions, you can always go back to our YouTube channel, just search for Oxygen Alliance, and you will be able to access all the previous sessions from there. We also have a website. We'll also paste the link in the chat, www.oxygenalliance.org. If you go there, you have a look and you'll be able to understand all the amazing work that the Oxygen Alliance is doing. So please go and check out these platforms. So reaching this far, I would like to wish you a great weekend, and we will see you again in our next talk. Bye, everyone.
Goodbye.
Bye.
Goodbye.
Bye.
Bye.